In this video, we're going to go over how to evaluate expressions involving exponents. Now, there's two methods to this, and different textbooks and different teachers teach it different ways. I'm going to go over the way that I think works a little better. A lot of people will, well, when they're asked to evaluate something, so numbers, it means to plug in numbers. A lot of people will just plug in the numbers right away. What I like to do first is simplify the expression with exponent rules as much as possible, and then plug the numbers in or evaluate them. Let's do it. Okay, so again, it says evaluate each. So each expression for f equals -2 and d equals 3. So those are the values that f and d will take on. What I'm going to do first is I'm going to look at this expression in A. It says 3 times f squared times d to the 0. Well, d to the 0, anything to the 0 goes to 1. So d to the 0 goes to 1, and that leaves us with 3f squared times 1, which is just 3f squared. So that's not bad. So now I have 3f squared. Now, since I have this all simplified, what I'm now going to do is evaluate -2 in for f. Remember that when we're evaluating in for f, we are squaring everything that f is. So I put parentheses first, and I plug -2 into the f spot. -2 squared is -2 times -2, which is 4. So this is going to be 3 times 4, which is equal to 12. Oh yeah. Let's go to letter B. I'm a little excited about this if you can't tell already. -6 times f to the -3 times d squared is what we're looking at. We can do a little bit of simplifying here. We can simplify f to the -3. The d squared is just going to stay. So this becomes -6 d squared all over f to the 3rd. Because we have that negative exponent up here, as we've seen in previous videos, we then bring the f to the -3 into the denominator. That's what the negative exponent acts on the f with. Okay, so now we're going to evaluate. So again, just like we did in the last problem, we have parentheses to group everything that's getting replaced for those variables. So d is 3, and we are squaring it, d squared, all over f cubed, which is -2 in parentheses cubed. Okay, so now all we have left to do is follow the order of operations with our exponents. 3 squared, exponents first, is 9. And some of you will be able to do this with a little bit more pace. Like you might do it a little bit quicker because you got your order of operations locked down in there. If not, I'm going to take my time with it here. -2 to the 3rd is -2 times -2 is 4, times -2 is -8. Ah, now it's up to you. You can certainly multiply this out and then simplify. I like to simplify first. I notice that a negative divided by a negative is a positive, and that 6 and 8 share a greatest common factor of 2. So this is going to divide out with -8, and 2 goes into 6 3 times and into 8 4 times. The negatives cancel out. So 3 times 9 is 27, all over 4, and improper fractions are always the way to go. That's it. Okay, last but not least on this side of the video, because we're going to be doing a second side of the video here with a couple more, slightly more challenging problems having to do with evaluation. So now here again, I'm going to simplify first. So I've got d to the -2, and with d to the -2 comes a little bit of simplifying, right? That'll go into the denominator. F to the -3 goes in the numerator. So I have f to the 3rd all over, the 10 is hanging out, d squared. Very important you recognize the 10 is not being raised to a negative power, and that's why it remains in the denominator. Okay, so now from here, I'm going to evaluate in my numbers, -2 for f, again, parentheses. So it's -2 cubed all over 10 times d squared is going to be 3 squared. And now I'm just simplifying. So -2 times -2 is 4, times -2 is -8. All over 10 times 3 squared is 9. So again, before I simplify and do 9 times 10, I notice that 8 and 10 can be reduced. 8 will become 4, and 10 will become 5. We're dividing the numerator and denominator by 2, and that leaves us with -4 over 45. Just a kind reminder, if you're having trouble with any of the simplifications of fractions, if you're having trouble with any of the order of operations, check out earlier videos in my pre-algebra and even math foundations courses and search out order of operations, search out fraction simplification so that you're in good shape on that stuff. All right, I'll see you on the flip side if you need a little bit more of a challenge or you're having trouble on more involved evaluation problems with exponents. And here we are on the flip side of evaluating expressions involving exponents. Stepped up the game a little bit in these examples where you're going to have to do a little bit more simplification using exponent rules and then plug your values into the corresponding variables. Let's dive in. This first problem says evaluate negative 4m to the third all over 6m to the fifth n to the negative 1 for m equals negative 2 and n equals 3. All right, basically, you're plugging in these values into their corresponding variables, but first, I'm going to simplify this expression. So, I've got negative 4 over 6, I've got m to the third over m to the fifth, and n to the negative 1. A lot to simplify. So, first things first, what I notice is I'm going to kind of take m to the third over m to the fifth. And what I do is I'm subtracting exponents, right? 3 minus 5 leaves you with m to the negative 2, which means that we have two m values in the denominator. So I have that. So I've got negative 4, and you know what? I might as well bring the n upstairs into the numerator, making that a positive exponent. So n to the 1 all over, and now I'm going to end up with 6m squared. So we've reduced the number of variables we have in the expression, simplified things a little bit. We can also simplify those coefficients, these numbers. 2 goes into 4 and 6 evenly, so 2 will go into 4 2 times, so I have negative 2n. All over, 2 goes into 6 3 times, so you're left with 3m squared. Now that this is in simplest form, we can evaluate, and once we do that, it's a little easier to plug in numbers. So n is 3, so I have n, well, that'll be 3. Negative 2 times 3 is where n was, all over 3 times m squared. Well, that would be negative 2 squared. This actually simplifies nicely. Before we multiply out, notice that these are the same factors. They'll divide out. 3 divided by 3 is 1. And we'll be left with negative 2 over negative 2 squared is negative 2 times itself is 4. And that can be divided numerator and denominator by 2 to leave you with negative 1. Negative 2 divided by 2 is negative 1 over 4 divided by 2, which is 2. Negative 1/2. Pretty sweet. Take your time with it. Go piece by piece, simplify first, and you're in good shape. All right, we're going to do the same thing here. So we've got the expression 2x cubed y to the negative 7th times y to the 5th. We're going to evaluate x equals negative 3 and y equals 5 into that expression, but not before we simplify the expression. So I notice here that there's nothing much that can be simplified. We could bring the y into the denominator, but I do notice that we're multiplying the y values, and I'd much rather add those exponents. So off to the side here, mentally I'm doing y to the negative 7th times y to the 5th. We have the same basis, so we add the exponents. Negative 7 and 5 is negative 2. Sweet. So I'm going to replace that, and we get 2x cubed y to the negative 2. That's our little more graduated expression. Y to the negative 2 is a negative exponent, so that will go into the denominator. 2x over y squared. And now we have an expression that we can just plug values into, right? It's in simplest form. So 2 times x is negative 3. All over 5 is going to go in for y. So 5 squared. And I'm still using parentheses just to be consistent. 2 times negative 3 is negative 6. All over 5 squared is 5 times 5, 25. And we notice there's no common factors between them before we multiply out, which means we know that negative 6 25ths is in simplest form. Oh yeah, peeps. Some good old-fashioned evaluating expressions involving exponents.